Hey, this is Edgar, and right now I'm going to be outlining a way to solve problems, like a methodology. And you'd want to have this, at least practice like solving problems in a particular process, just to get into that mindset of like what you need to do to get from point A to point B in solving a problem. Because often, like in interviews and in real life, if you just jump into some action without thinking about it, it typically doesn't go well. And especially in interviews, they won't be able to get a signal on like how you're thinking about this problem, like what steps are you taking mentally to get to the solution. And this could be really bad if they don't know, because then they can't help you, and also they could be thinking that you've just seen the answer already, and that's kind of cheating. It's not really it's pretty frowned upon. But yeah, this is what I like to do when I'm solving a coding problem or just any problem in general. First thing I like to do is I like to first write out the problem statement, but not word to word. I want to restate it, and I restate it just so I can have like a mental clarification on like the boundaries and the context of the problem. So what you want to do is restate the problem. And what I also like to do when I'm restating a problem is I like to throw out as much jargon as possible and just make it like as human readable as possible. So I'll go for an example after I outline all the steps I take to solve a problem. But yeah, after you restate the problem, what you want to do is give out some input and outputs, or in a less computer sciencey sense. If you had a solution to this problem, a correct solution, what's something that would go into that solution, and what do you expect your solution to accomplish? So for example, if I wanted to get from here to a movie theater nearby, I would use my solution to be a GSP. A GSP? No, is it? I'm thinking of Smash Bros, but a GPS. And what I'm expecting from the output is a quick and easy route from my house to the movie theaters. There's a lot of other steps I can do, but yeah, basically, this is just like showing the expectations for your the scope of your problem, like what should go in it and what should go out from like the solution you create. And then after, what I like to do is write a whole bunch of observations. And it's just basically like a lot of little mental notes and clarifications I've had, whether I'm asking like the interviewer, or if I notice something that they point out in the problem statements or in the inputs and outputs, I would write down the observation. If I know any like math or like just trivial knowledge about the subject, I could also write it down here. And if you like missing out stuff that you want to like observe, you can always just kind of outline what you think a solution would entail, like what would it have. And then finally, write out the algorithm to solve the problem. When you write the algorithm to solve the problem, what it means in more layman terms is just what are the steps to accomplish this problem that you're given, and this would be your solution practically. And the first time around, you can just the goal is not to like think of the best way to solve a problem, but just a way to solve the problem. Because from those brute force ways, you can easily try to expand it and like build on it to find more optimal solutions. So yeah, in the case of solving coding problems, I like to also, after creating my algorithm, just do a quick time and space complexity analysis of what's like of my solution. Yeah. And I do this just so I can like have like a benchmark of how optimal my solution is at this point. And typically, if it's not like linear or like logarithmic or even constant time, you could probably do better. I read books actually, and this is my mindset going forward a lot of the times, that always think you can do better when you have a solution already, because it usually is a better way to do things. So these are the 4 steps I usually take to write the solve a solution or solve a problem. So let me just use an example, and I'll use this template to solve that problem. So let's do something very easy, like a classic coding interview problem. They don't really ask this anywhere, but this is typically a problem you get asked. like when you're starting out and like you're teaching yourself how to do interview problems, is FizzBuzz. What is FizzBuzz? So given a number, print out from 1 to n, which is the n being the number that you are given, a bunch of like what's it called again, outputs, or you can add it to a list depending on a few constraints. So if the number you're printing on at this certain iteration is divisible by 3 or 5, then you print out FizzBuzz. If it's only divisible by 3, then you print out Fizz. And if it's only divisible by 5, print out Buzz. And if it's not divisible by either, you just print out the number itself. So let me just try to restate the problem. I should say FizzBuzz, but just so I'm not like being a smart aleck about it, I'm just gonna write down what this problem entails. So, given a number from 1 to that number, print out a series of lines depending on condition. So some of these conditions, as I stated before, is if divisible by 3 and 5, print out FizzBuzz. If divisible by only 3, print out Fizz. And if divisible by just 5, if divisible by just 5, print out Buzz. And then finally, if none of the above are true, just print out a number. Print out number. So this is the problem. Excuse my very messy handwriting. Input and output. What should my solution take in as an input, and what should be the expected output? So input, if I'm given n equals 15, the output should look like 1, 2, Fizz, 4, Buzz. Is it Buzz? Yeah. 6. Oh wait, 6 is divisible by 3, so Fizz, 6, 7, 8, 9, Buzz, and then so on until you get to 15, and 15 is a number that is divisible by 3 and 5, so at that point you print out Fizz, Buzz. So that's basically how what the problem is wanting you to solve, like how do you program this program. There isn't a lot to note or to observe in the solution, but I can say that I could assume that the time complexity of the solution should be linear, so O of n, because we had to loop through every single number to calculate whether it is divisible by 3 and 5 or all of this. To check all this, we have to check it with every single number. And to do that, it has to be linear time complexity, because we have to check through every single number. So yeah, my only observation would be O of n likely. At this point, you can also ask some clarifying questions to your interviewer. So I would say something like, oh, do you expect me to just print this into the console? Or would you want me to return a list full of all of these values? So yeah, once you get a confirmation, you can also add that to your observations. For the sake of simplicity, I'm just saying print to console. And what else can I say? I guess for the math involved in this, I know you would have to use modulus. So modulus in programming is basically like, it calculates, it does like division, but it gives you the remainder. So if you were to do modulus, a number and like 5, if it gives you 0, that means it's divisible. And if it gives you like 1, it's not divisible by that number. So we're going to have to make use of the modulus operator. So yeah, given that I stated the problem, some inputs and outputs, and some observations I made, slash notes, I can write down a quick algorithm. So my algorithm will basically be, just to make this really fast, because this video is probably a little bit too long, it's just going to be copying and pasting all of these checks at every single number. So I'm just going to put this in its own little namespace. It's just checks. Checks for short. First, loop from 1 to n, whatever n is. Also, when you're writing out your algorithm, make sure to state that you're writing pseudocode, because you don't want to be mistaken for writing Python or anything like that. You want to make it clear that it's like it's just the recipe for solving the solution. And for me, I typically do that by just writing like little slash marks next to it. But yeah, loop from 1 to n, checks. If checks are true, print corresponding result. Print result to console. And after the loop is done, the function is done, and that is our algorithm to solving pit bugs. So as I said, after I do my algorithm and I outline a solution, I like to do the time and space complexity of the problem. So the time complexity of the problem will be O of n being whatever number we're given, because that's how much loops we have to do to get to print out every single value and what kind of like phrase it will spit out. And the space complexity will be O of 1, which is constant, because we are not creating any extra space at all, even, especially not creating any space that's dependent on the input given to this function. So yeah, this is how you approach solving a problem, or one of the many ways. This is my ideal approach. For the next few videos I do, I will be writing out like my solutions like this. I like thinking through it in this way as well. Just to give myself the practice and just to give you guys some idea like how to do this and just like apply it to different problems. Eventually I won't do it for every video, because some like algorithms and some coding questions don't really warrant too much thinking like this. Maybe some pretty pictures and stuff, but yeah, not anything so full blown as this. But yeah, I hope you learned something from this, and thank you so much. I will talk to you another day. Thank you.